Okay, so what I'm going to do here is I'm going to be prototyping this um, relay switch circuit. One of the things that I pointed out and really stress about electronics here is that my digital electronics, including my 555 timer here, it only outputs 5 volts. So it does all these clever timing things and whatnot, but what if I need to power something that requires more than 5 volts? Here's an example. I'm going to run a motor off of a 555 timer. So what I do is I use the timer's output, which is 5 volts, to energize a coil that magnetically closes a switch. So then that switch is connected to a higher voltage, in this case 9 volts, which allows me to run a motor. So when I do this in the simulation, this is everything on the left of this is my basic monostable. I push the button and it goes hot for a certain amount of time that depends on the resistor capacitor combination. Now here in my monostable, I've inserted a pot, the potentiometer right here, and that allows me to control the length of time. This might be a desirable thing. We used to have events in Science Olympiad, for example, it was an electric vehicle thing, where a little electric vehicle had to run for a certain amount of time and then stop. Well, this circuit would be perfect for that. I would hit the button and off the car would go, and it would run for a specific amount of seconds and then turn off, no matter how powerful the motor needed to be, because the power is supplied by relay. So what I have to do is make just a few changes to my basic monostable. So what I did was I went back to the basic monostable. Here, this is my basic monostable. I'm just going to add on this extra circuit. So what I did, and I didn't instruct you to do this, but I felt like it was a really convenient way to keep things orderly, is I put the relay here on its own little mini circuit board. So there's a little extra circuit. I have my 9-volt battery here. I open this up a little bit. I have my 9-volt battery, and I have this motor that I'm going to drive. Now, my monostable here has a couple of little modifications to it that I had to make so it would match the assigned circuit here. I don't think our original monostable that we did as an assignment had a potentiometer in it, so this potentiometer I added. Now notice I go from 5 volts to here. I move the potentiometer so that you can see where that 5 volts is when I move this back into position. So this pin is 5 volts. This middle pin is the wiper, and then from the wiper I go to the discharge and the threshold, which links to ground through a 10 nanofarad capacitor. I still have the control setup that I had on my basic monostable with a 10 microfarad capacitor off of that. I still have my push button. One thing that's changed here, you'll tell, is a difference from the one that I spec'd out for the monostable. This resistor is now 10K instead of, gosh, I don't remember what it was on the other one. It may have been 4.7K. The value of this resistor makes very little difference. I'm pretty sure this would work with 4.7K. The point is, it's being used as a pull-up resistor for this switch to make sure that I get a good 5 volts at the input. What changes about this is what I do for the output. So I pretty much already have all of that build. For the output, what I'm going to do is I'm going to go from the output through a diode on my way to my relay. So let me just do that first. I have a diode here, and I'm going to hook the diode to the output. You see, there's the output right there. So the diode goes from the output this way. Notice the gray line on the diode. That indicates the direction the current is meant to flow through the diode, and so it's important that I keep that right. Now, this diode then is going, ignore this diode for a second, is going straight into the coil on my relay. So I'm going to look at the relay, see how the diagram is written on the relay. It's really small here, but I have 2 connections, and then I have the coil, and then I have 2 more connections. So if I go along the top of the relay here, there are only 3 places to connect to, 2 that are close together, and 1 that's way over here. The one labeled terminal 5, that one is the coil. So I'm just going to go ahead and hook my coil right there. That works out beautifully, connecting the 2, and it lined right up. Gee, I wonder how that happened. So now I've got that connected to the coil. and we'll see what else we have to do. So that goes into the coil, and the other end of the coil is connected to ground. See, the coil is here, but that wire is connected along with all of this connected to ground. So I'm going to take the other side of the coil, which is right here. It's terminal 8 on the opposite side there. Now this terminal needs to be connected to ground. How am I going to get there? Well, I have a ground here, which I'll bring over to here. And then I'll take this and then bring it over to here. That way I've connected terminal 8 to ground. But that bottom part of the coil also goes back through another diode back to the other side of the coil. And I had mentioned that the reason for this, and here it is here, I'm dropping it in with the diode going in this direction. The reason for this is that coils have this property that they resist changes in current. So when you turn them on and turn them off, they actually resist the change. These diodes force the current to flow in only one direction, which means when it's time for this relay to get shut off, it shuts off immediately. If I didn't have the diodes, it would there'd be a long delay, potentially a long delay, depending on the resistors in the circuit. There'd be potentially a long delay before the thing threw back again. So now I've got it set up so that my output is going to energize the coil inside the relay. All I have to do then is get the relay to fire up this motor over here. So the relay is keeping the motor separate from its power source. But one side of the power here, I'm going to come off this, and I'll go this way. One side of the power I am going to hook to the motor. Right? But just hooking the one terminal up isn't enough to run the motor. If I want to run the motor, then I would have to hook both of them up. But if I hook both of them up, what's going to happen is the motor is going to start running immediately when I run the simulation. As a matter of fact, start simulation, bzzz, off it goes. The motor running. So I want the relay to be in the way of that. So I'm going to take the positive terminal of this 9-volt battery here, and I'm going to run it up here to terminal 1 on my, that's a little bit untidy, I can fix that right there, that's nice. And I run up to terminal 1 on the relay. Notice that terminal 1 is currently not connected to terminal 6. Terminal 1 is not going to be connected to terminal 6 until the relay becomes energized. So I'm going to run terminal 6 over here. Now, when I start the simulation, you'll see the little bugger. Oh, you know what happens there? It when you start the simulation, it automatically runs the timer. We noticed that little bit of a snag before. So now here it is. The motor's not running, and it's not going to run until I push the switch, which will energize the output pin on the 555 timer, which will then drive a current through the coil of the switch, force the switch to throw, which will allow the 9-volt battery to power the motor. So if all goes according to plan, won't make a fool out of myself here, I press the button and the motor runs. And the motor runs for the specific amount of time depending on how I set the potentiometer. So now I'll change the potentiometer to a lower value and we'll watch what happens. I run the potentiometer and it runs for a very short period of time. If I run it down even further, then I run it and it runs for a very short period of time. If I turn the potentiometer knob this way and I run it, it'll run for a significantly longer time. This time depends on the value of the resistance in the potentiometer. Now this pot that I've installed here, I didn't mention, I think I stopped the simulation, I didn't mention before, but this potentiometer has a maximum resistance of 500K. And so that 500K resistance scales how long it'll run for, maximum to minimum. And perhaps if I was doing this for like a project, I might install this knob in a panel and put some tick marks on there so I could tell how many seconds I get. I can calibrate it by determining what knob positions get me how many seconds, and then I could roughly set the thing so that the motor will run for the appropriate time. So there it is, the relay switch.